So here we have a 9 kilo paint box which is kept on top of a 1.2 kilo wooden block which is placed on a roof which is slanting at an angle theta. So we can find the angle theta is tan inverse of opposite upon adjacent, 4 upon 12. So this gives us a value of 18.43 degrees. Now what they've asked is the magnitude and direction of the frictional force exerted by the roof surface on the wooden block and the normal force exerted by the roof on the wooden block. So since the roof is slanting, there is a component of the gravitation which tends to slip it downwards. The force is acting downwards, so it slips to the right. If it is sloping to the right downwards, so it slips to the right. The friction will always oppose this movement, so the friction will act up the roof, along the roof, and it will act in the upward direction. So if you have to draw the free body diagram, let's start with the free body diagram of the paint box. So we have the M1G, if M1 is, so that is 9 kilos, acting downwards. So the normal force, the force exerted by the wooden block on the paint box is upwards. Coming to the wooden block, so this is the wooden block. The force N1, the normal force N1, on the wooden block it acts downwards. So the paint box is exerting a force, normal force downwards. M2G, that is the gravitational force, 1.2 kilos, is acting again downwards. The normal force due to the roof will act perpendicular to the roof. And the friction force we just discussed, it acts upwards. So suppose we consider in the vertical and horizontal direction. So N1 and M2G are already in the vertical direction. We'll resolve the force N2 and the frictional force. So N1 and M2G, that's already in the vertical direction. So let's resolve N2. The roof is making an angle theta with the horizontal. So the perpendiculars to these two angles, the perpendicular to this side and the perpendicular to the horizontal. The angle between these two perpendiculars will also be theta. So angle between the perpendicular and horizontal means vertical, and the roof, the normal to the roof. So that is theta. And theta we already calculated. So we have that this force N2, the normal force N2 can be resolved into a vertical and horizontal direction. The adjacent angle will be cos. So this would be N2 cos theta. So I may write it over here. This is my N2 cos theta. And the opposite side is N2 sin theta. The frictional force, so this is the adjacent angle, this will also be theta. So that can be resolved into a vertical and a horizontal direction. Since it is acting upwards, so the horizontal direction will be acting to the left, the vertical direction upwards. Again, this is the adjacent side. So this is friction force Ff cos theta, and my vertical would be Ff sin theta. So the horizontal forces are getting balanced. So I have in the horizontal direction, if the body is to be in equilibrium, summation Fx is 0 and summation Fy is 0. So summation Fx is N2 sin theta is acting to the right, that is equal to the frictional force cos theta, and in the vertical direction, so summation Fy is 0, we have N1 is downwards minus N1, N2 cos theta is upwards plus N2 cos theta. The other horizontal, the vertical force is Ff sin theta, which is acting upwards, plus Ff sin theta. M2G is acting downwards, minus M2G equal to 0. From a previous sum we have N1, from a previous free body diagram for the paint this thing from the previous page we have N1 is equal to M1G. If I substitute N1 as 9 kilos, I know the value of theta. I can get the unknowns normal force, N2, and the friction force. Normal force exerted by the rope on the wooden block, and the friction force, as I have got two unknowns and two equations. Solving them, we get the value of N2 as 94.93 newtons and the frictional force is 31.63 newtons, acting in a direction like this.